Lesson 12 is going to examine or let us experience what happens when factoring isn't working so well. So this is called overcoming obstacles in factoring. So let's say we try to continue a problem similar to like lesson 11. And it says find all the real solutions to the equation. And you say, okay, I can do that. That's going to be easy. I'm going to open up a set of parentheses. I write x and I write x. I think of something that multiplies equal 3. The only thing I can think of would be -3 and -1, because I know I have to get a negative here in the middle. And then I say, okay, let's check that. I get -3x. I get -1x. And when I add that up, I get -4x. Wait a minute. That's not okay. I'm supposed to get -6. And so I think, well, okay, let's just start over. I did something silly. And we put parentheses, and we put x squared and x squared, and that's right. Well, maybe it is +3 and +1. So we get 3x, and the little squares shouldn't be there. We'll take those off. I wrote too hastily. And then we come over here and we say 1x, and I get +4x. Well, that's not -6x either. So I got to thinking, okay, maybe I can't solve it. So if I can't solve it, right, let's try something else. What if I tried graphing it, right? So what if I said x squared -6x, and I put in +3. Well, that's interesting. It says there are answers. It says 0.551 and 5.449. Like, okay, I have no idea what that means. So what do I do? Because clearly I can't factor this. There's no way I'm going to come up with those two values. So this leads us with two non-factoring options. One of them is called complete the square. Let's make sure we write complete right. The square versus the quadratic formula, right? So we do have to practice both. We have to know how to use both. The practice set is going to ask us to demonstrate both. And so we're going to start with complete the square and show how this process works. So why is this not working, right? So we take a look. Let's examine deeper this x squared -6x plus 3 equals 0. Let's look at that one more deeply. The problem we ran into is we could not think of anything that multiplies to equal 3 and adds to equal -6. So if that's the case, I'm going to get rid of that 3. So this is going to be, by the way, if I didn't make it clear, we're going to demonstrate how to complete the square. So if I don't like that 3 there, and I want to put some number there, I'm going to kick the 3 out. So I'm going to remove it. Not by erasing it. I'm going to take and I'm going to move it to the other side. 0 plus -3 is -3. So for those wondering how did he magically do that, right, I simply used my algebra skills and I -3 on both sides. So now that leaves an opening, right? I have a space for a new number, a number that I would like to have. Now, I'm sure you could probably think of some things that may work, but we're going to use a special design to help us get there. It's going to be called b divided by 2, and we're going to square it. This is going to give us our new c value, the number that we want to replace this with. So if you're wondering what the B stands for, right, all of our polynomials are written in the form of ax squared plus or minus bx, and then plus or minus a c. So our b is -6. So if I was to plug in -6 into here, that would give me -6, divide that by 2, and then I'm going to square that. So -6 divided by 2 is -3. And if I square -3, I'm going to get a 9. So we're going to put a +9 here. Now, if you remember anything from Algebra 1, that's very important for equations, is if I'm going to put a +9 on the left, I have to be fair to the right-hand side, and I'm going to have to put a +9 on this side. So now my problem looks like this. X squared minus 6x plus 9, and we can combine these two to get a 6. So now I can complete the square. Right? Now I have something that I can actually work with and factor to make it do what I want it to do. So now, if I take a look at this, I could say, well, and I'm going to write this out. You're going to notice something in a minute. I can write x, and I can say, oh, I know something now. I could put -3 and -3. Again, we can check that, right? Just to make sure, because remember we had trouble last time. This is -3x. This is -3x. If I add those together, I'm going to get -6. It worked, right? We're in business. That's what we wanted to have happen. So now that we know this works, turns out if I've got x minus 3 and x minus 3, that is the same thing as saying x minus 3 squared equals 6. So what we're going to do is we're going to solve, right? How do I get rid of a square? I square root both sides. So that means x minus 3 is going to equal the square root of 6. I square rooted both sides, right? So plus or minus. For those wondering where did that come from, right? I am choosing to square root both sides. That allows this radical here to cancel that square. So all we're left with is x minus 3. Anytime I do a square root on both sides, I have to put this plus or minus in the front. And so now we're almost done. We're going to add 3 to the other side. So x is going to equal 3 plus or minus the square root of 6. That's going to be our result. These are two answers, by the way. So we'll emphasize that. One answer is 3 plus the square root of 6. And the other answer is 3 minus the square root of 6. Those are our two answers. Turns out if you put those in your calculator, right? If I was to type in 3 plus the square root of 6, where's the square root? Square root of 6. I'm going to get approximately 5.449. Let's make that look like a 4. And it continues on. And if I did 3 minus the square root, let's see, 3 minus square root of 6, I'm going to get the 0.55 and so on. So if you remember in our graph, we had the 0.551 and the 5.449. That is the approximated decimals for the exact answer that we got completing the square. Now that is two of our solutions. We also have this one right here. So in this one, I'm going to demonstrate the quadratic formula. So we model complete the square. We can complete the square for this one, but some advice is anytime that you have a number that is here larger than 1, I would recommend the use of the quadratic formula. So what is the quadratic formula if you have forgotten from Algebra 1? it would be opposite of b plus or minus, and then you have b squared minus 4ac over 2a. Now, what do all these a's and b's and c's mean? Remember, that's what we talked about before. This is ax squared plus or minus bx, and then plus or minus c. The quadratic formula is more or less a formula you're going to fill in. So when I'm solving it, right, it says opposite of b. So my b is negative 4. So the opposite of that is 4. So I put 4 plus or minus. We put a radical. We're going to put negative 4 squared. This minus 4 is already part of the formula. My a is 2, so I multiply this by 2, and my c is negative 7. So I put a negative 7. I like to put all that in parentheses so we don't mistake those as minus signs. And then we divide that by 2 times a. The a is 2, so we put 2 times 2. And what we're going to do is we're just going to simplify this as far as we can. So the first thing we're going to do is we're going to simplify the inside. So we're going to put 4 plus or minus. We're going to put a square root. We're going to find out what number that is. So negative 4 squared minus 4 times 2 times negative 7. And we're going to get 72. And then in the bottom, in the denominator, we have a 4. So now we need to simplify this as far as we can. Remember our section where we talked about simplifying radicals, where we're going to simplify anything that's perfect in this 72 out. So now I can write 4 plus or minus. We're going to replace that 72 with 36 times 2. Right? 36 is a perfect square. So the square root of 36 is 6. So now I'm just going to draw an arrow up here to the top. So this is where our work's going to go. So the square root of 36 is 6. We leave behind a radical 2 over a 4. Almost there. So something can divide into a 4, a 6, and a 4. We can't do this one because it's inside the radical. So a 2 divides into both, in all three of these numbers. So 4 divided by 2 is 2. 6 divided by 2 is 3. We leave this radical 2 here. And 4 divided by 2 is 2. So this is generally our answer. We can simplify this a little bit further by writing 2 over 2 with a plus or minus 3 radical 2 over 2. And so that would equal 2 divided by 2 is 1. And then plus or minus 3 radical 2 over 2. These would be our two answers, a positive version and a negative version. So if I was to write that out just so you can see it, one version would say 1 plus 3 radical 2 over 2. The other one would say 1 minus 3 radical 2 over 2. And so we get 4 answers in that design. So complete the square, quadratic formula. These are what we're going to generally practice in this design in terms of how it works out. And again, my recommendation is if the coefficient here is a 1, I would complete the square. If the coefficient is a larger than a 1 and it can't factor, I would recommend quadratic formula. That's just kind of the way you could do quadratic formula for all of them, but you are going to have to know how to complete the square, and you are going to have to know how to do the quadratic formula. So you want to make sure you are practicing both in each design. I may swap it out in a minute and show you the reverse, so that way you can see a harder complete the square. So here's exercise 1. Right, they want us to factor and solve for anything that we can solve for in this design. So this is exercise number 1. I don't know that either of these can really be factored, to be honest with you. So I think we're going to have to complete the square or quadratic formula, but we'll give it a look-see. If I was to attempt to factor this, right, we would write x and x. This would have to be a -4 and a 1, but that's not going to add up to equal -2. We can erase these out. We could try something else. We could try -2 and +2, but that's going to go to 0. So I don't think anything's going to work here. So we're just going to go to another method. Let's say we complete the square, right? So that means if I'm going to complete the square, I'm going to write down my problem, set it equal to 0, and this seems to be the value that's giving me a problem. So we are going to remove it from the equation by adding 4 to the other side. Remember, we're going to apply our little design of b divided by 2 squared. My b is -2. So that means we're going to do -2 divided by 2, and then we're going to square it. So -2 divided by 2 is -1. We square that, we're going to get a +1. So we put a +1. And what I put on the left, I have to put on the right. So now when I factor this out, I can now get x minus 1 and x minus 1, which is the same thing as x minus 1 squared. And so 4 plus 1 is 5. We get rid of the square by square rooting both sides. So now I'm going to get x minus 1 equals, remember the plus or minus anytime you square root, with a 5. And I'm going to add 1, so x is going to equal 1 plus or minus the square root of 5. So that's going to be 2 of our solutions. We can try and factor the other one, right? It never hurts to try. So I'm going to open up a set of parentheses. Let's make that look a little bit nicer. So a set of parentheses, we're going to try to factor. I got 3x squared, so I can write 3x in this one. And I can write x in this one. We need to get a -3, so maybe we can try a +1 and a -3. So let's see what happens, right? This would give me a 1x. This would give me a -9x. And if I add these together, I get -8x. That is very close. I need a +8x. So if that's the case, what I can do is I can go back and see maybe if I rearrange the sign values. Maybe if I take these two signs and I swap them. So let's say maybe we make this negative and this one positive. Right? So let's check that. -1x. This is 9x. If we add these up, we get 8x. So that's going to work. So this one's actually factorable. Right? So if that's the case, that makes the work here easy. I can take this one and I can set it equal to 0. And I could take this one and I could set this one equal to 0 and I can solve. I add 1, so I get 3x equals 1. I divide by 3, and x is equal to 1/3. And then I minus 3, so x is equal to negative 3. So those end up being my 4 solutions. Of course, remember, I can always check this in desmos.com using my computer if I have any uncertainty about whether the answers are correct or incorrect. So remember, we are studying this idea where we could have potentially we could factor. That would be ideal. If factoring doesn't work, we want to consider complete the square. Right? Remember, I recommend, so a recommendation, that a should equal 1. You can complete the square if it's greater than 1, but it's a little bit harder, and I'm going to show that a little bit later. And then we have quadratic formula. And that's recommended if a is greater than 1. And if you need to write that down again, that would be opposite of b plus or minus b squared minus 4ac over 2a. Make sure all that's under the radical. And so these are our 3 options that we are currently practicing. So one more thing that comes up is, what if we have something like this? What if we have a cubic? Right? We've got 1, 2, 3, 4 terms here. And so this is going to be considered factor by grouping. So another option that can come in is factor by grouping. So this is another challenge that we run into. So in this case, what we're going to essentially do is we're going to examine the front half, and we're going to examine the back half. We're going to separate them a little bit. And what we're going to do is we're going to take advantage of greatest common factor, GCF, to try to see where it goes. So like if I look at this first part right here, they have in common an x squared. So I can factor that out. Left over, well, so x to the third divided by x squared would be x. And then 3x squared divided by x squared would be positive 3. So we have our minus sign in the middle. We'll do the same thing again. Greatest common factor of 9 and 27 is a 9. So we open up our parentheses. 9x divided by 9 would be x. And then 27 divided by 9 would be positive 3. Now, for those who argue, wait, shouldn't that be a negative 3 in there because it's a negative 27? Let's go back and check. If I was to do distributive property, negative 9 times x would be negative 9x, and negative 9 times 3 would be negative 27. So I do want a positive 3 in there. The other reason why I want a positive 3 is because of what I'm attempting to do. Notice here, I've got a x plus 3 and an x plus 3. I just created a new greatest common factor. They happen to both have an x plus 3. So if that's the greatest common factor, I can write that down. The new GCF, again, is x plus 3, and the remaining factor is going to be x squared minus 9. Right, so now we have this idea. And a keen observer is going to realize that this is a difference of squares. So now I can further factor this. So now I've got x plus 3, and this can be x minus 3, x plus 3. And so we have that factored in. So now I can solve for zeros. I can say x plus 3 equals 0. I can say x minus 3 equals 0. And I can say x plus 3 equals 0. So I get x equals negative 3, I get x equals 3, and I get x equals negative 3. So when I look at this, my final answer would be x equals negative 3 with a multiplicity of 2, and then I'm just going to have an x equals 3. And if you want to write a multiplicity of 1, you're welcome to do so. That would be the final answer for this particular problem. So again, this is factor by grouping. So if we recap, what did we do? We put parentheses for the front two, parentheses for the back two, pulled out greatest common factors. That created a new greatest common factor of x plus 3, which we pulled to the front, and we wrote the remaining factor pieces in the back. Fortunately for us, we ended up with a difference of squares this time. That does not always happen, but a lot of times you'll see something like that happen, and then you'll factor. All right, so we looked at exercise number 2. Exercise number 2 asks us to attempt the same thing again, right? So we're going to factor by grouping. I would recommend here you pause the video and try. I'm going to keep solving for those of you who don't want to pause the video. So I'm going to put a set of parentheses here in the front and a set of parentheses here in the back. The greatest common factor for this one is x squared. Left over is going to be an x minus 5. And so the GCF of the next parentheses is a 4. And so we're going to have an x. And then we're going to have here a minus 5. Again, how do I know the minus 5 is going to work? Because I need to be able to generate this negative 4x plus 20. So if I distribute this, I'm going to get negative 4x. And if I distribute this, I'm going to get positive 20. So I know that that works out to how we want it to look. So now that we have that, we have a new greatest common factor, right? So we'll take these off. So my new greatest common factor is x minus 5. And left over is going to be x squared minus 4. Again, I notice a difference of squares. So now I have an x minus 5 with an x minus 2 and an x plus 2. So we solve each one. This one is going to be x equals 5 when we're done. This one would be x equals 2. And this one's going to be x equals negative 2. These are my 3 solutions. How did I know I was expecting 3 solutions again? Because I've got this 3 in the front. That's my leading coefficient, or leading, not coefficient, but leading degree. And so I am expecting to get 3 solutions in this problem. So there's only one more thing left in this lesson. That's exercise 3. They give us one more factor by grouping to try. Of course, I recommend you pause the video and try this one, particularly if you have not tried exercise 2 or example 1 by yourself. You really want to try one on your own, and so you should pause it. I'm going to continue. For those who have solved it and have unpaused it and ready to go, we're going to group this front part. We're going to group this back part. And so the greatest common factor is x squared, and on the inside will be x minus 8. So that's what we're going to try and get in the other parentheses. So we put a minus. Here the greatest common factor is a 2, and we're going to have another x minus 8 here. Again, to confirm that we know this works, if I was to distribute this, I would get negative 2x. And if I distribute this, I'm going to get positive 16. Remember, we want to be able to generate the values we had in the original polynomial to confirm it's correct. It does not hurt for anyone to try to check that before you proceed. Do not assume you're going to always get the same number, because if you don't, then this may not be factorable. So our greatest common factor, our next one, is x minus 8. So now I'm going to have an x squared minus a 2. So this one's going to be different, right? This is not a complete difference of squares. It is, but it's not as easy one to see, so we're going to solve it differently. So we set this one equal to 0, and we get x equals 8. And then we're going to set this one equal to 0. So if we don't recognize this as a difference of squares that we can solve easily, we're just going to solve it the way we want to. Traditionally, is get x by itself. So we're going to add 2 to both sides. So we get x squared equals 2. And then how do we get rid of a square? We take the square root. And so we're going to square root both sides. So we have to put a plus or a minus anytime we do that. And that ends up being our other two answers. How do I know that that's satisfactory? Again, my degree here is a 3, so I'm expecting 3 answers. This 8 is one answer, positive radical 2 is another answer, and negative radical 2 is the third answer. All right, so I hope this lesson helped. And if you have any questions, let me know.